So this is the sample prep for our hard water lab. So what I'm going to do here is I'm going to take this Erlenmeyer flask, I'm going to zero this, and I'm just going to add a little bit of calcium carbonate to it. Okay, that should be plenty. So 0.21 grams it looks like. So I'm going to record that. Now what I'm going to do is I'm going to take this and I'm going to go ahead and add some hydrochloric acid to it. Let's scoot over here a little bit. And the hydrochloric acid is going to do is it's going to take that calcium carbonate and it's going to react with it to form calcium chloride. And that's going to then dissolve this pretty insoluble compound. Put a little water there. Let that react. So when that's done, fizzing, I'm going to go ahead and wash the sides to make sure I have everything, and then I'm going to heat that using a hot plate. And that's going to allow me to get rid of the hydrochloric acid. So the hydrochloric acid is going to become a gas, leave that solution. So that way I'm left with just a calcium chloride solution. So here we're going to run the blank while our solution is warming up. I'm going to take 25 milliliters of distilled water and add a little bit of buffer, 5 milliliters of that. And that's going to keep my pH under the right conditions to get this reaction to happen correctly in a way that benefits me and gives me a good endpoint. Then I'm going to add some indicator. So here's the Erichrome Black T. Just a little bit of that. Okay, now normally that would make this turn blue. However, the pH indicator has an indicator of its own in there. Then, so it already was blue, I'm going to add 15 drops of magnesium chloride. Now you want to do this in a way that's consistent. So every time you do this, you want this to be the exact same kind of 15 drops. Okay. So now that I've added 15 drops, you're going to note that when I swirl this, it's going to change from that blue color to kind of a wine purple reddish color. Okay. And what we're going to do is we're going to titrate that to figure out. So that's going to give us our endpoint, but that's also we're going to do that every time, and so we need to be able to subtract that amount of EDTA. All right. So for the titration, we're going to take this burette here, and we are going to let the last of the rinsings kind of go into a waste jar here. And we're going to go ahead and refill this. Okay. And so I have some samples that I ran yesterday. This is the blue color we're looking for, and so we're going to record where our starting point is. It looks like 3.4, and we're going to start at 3.4 milliliters, and we're just going to add it. It's going to be pretty quick. This changes color in terms of volume added, but it's going to take a little bit of time to get to that endpoint without going over. See a little bit of blue color there when I'm adding that, so I'm slowing down. it's getting close. So now I'm definitely seeing a blue color. It does look slightly different than the one next to it. So I might add one more drop here. But let's go ahead and look at the volume here. So we are currently at 8.62. Let's try one more drop. We'll see if we should stick with that or not. Alright, that still looks a little different, so that must just be from different amounts of buffer. So 8.62 will be our final volume. So right here we're heating our sample from before. This is the calcium carbonate with hydrochloric acid added to it. And the reason we're doing that is so that we don't have acidic solution when we're done. We don't want it to be, we want the pH to be up by 10. That's where we use that pH 10 buffer. So we need to drive off all of the hydrochloric acid. So if we're doing this as a class, this is something we'd want to do in the fume hood. For right now, just with the one, I've been doing it off to the side on a different table in a different part of the room. But that hydrochloric acid, as it's boiling, is leaving with some of that steam, but the calcium is staying all behind. So to continue on our sample prep here we have our mixture that we've kind of created. We're going to pour this into a volumetric flask, and then we're going to dilute the whole thing to be 500 milliliters. Now there's a little bit of that left in here, so I want to make sure I get that. So what I'm going to do is I'm going to add my distilled water to here, swirl, and then pour that in. And I'm going to continue doing that until I get to 500 milliliters. So now that we have our 500 milliliter solution and I've rinsed out the pipette, we're going to take this and we're going to fill this up with 10 milliliters of that calcium solution. Okay, and we're going to take that and put that into the Erlenmeyer flask. Then we're going to add a little bit of distilled water to that, just to give it some volume. Kind of like a hairdresser here. Then we're going to add our buffer. Okay, and we're looking for the blue color to kind of be there, to show that it's actually at a pH of 10. At this point now we can put, oops. We can put our indicator in, just like before. There's our Erichrome Black T indicator. Okay. And then again, like before, we're going to add the magnesium chloride solution, 0.03 molar. And we're going to do 15 drops, and then we're going to do a titration on this and compare it with the results of the last one. So. Okay, there's 15. And hopefully when we give it a swirl, it gives us that red color. It's a little purple, but that'll work. So now we're going to go ahead and do our titration with the burette, just like the last one, but this one should go a little bit longer. So we are starting where we left off. It's like 8.7. I'm going to let quite a bit run through here. I know I'm going to need to do about as much just to get rid of the magnesium, plus some additional to get rid of that calcium. So we're going to let this kind of get to a point where we're going to start to see some blue color flash in before we slow it down. So I'm going to start off our titration pretty quickly for your sake and mine. And I think I'm starting to see some blue. Pull this up so we can compare the two. This is from our blank that we did with just the magnesium chloride. So it's getting more difficult to tell. This still looks a little bit more purplish to me, but it could be just the amount of indicator used. I'm going to mark where I am now. Looks like I'm at 28.5. Just to kind of confirm or deny, I'm going to add quite a bit here real quick. Let's see how that changes color. So it does still look a little different to me. So 28.5 will be our final reading there. Looks like that's from the indicator. So from there we can go ahead and figure out how many moles of EDTA we have based on the fact that we know how many moles of calcium are in that solution. Now we can go ahead and run our final one, which is going to be our tap water. So now we're actually going to go ahead and test our tap water. This is 22 milliliters of tap water. Get that in there as best we can. So same process as before, we're going to add the buffer. Okay. We're going to add our indicator to indicate when our color change occurs. And we're going to go ahead and add our wrong vial, magnesium chloride, 15 drops. Note that the color's already changed on this one, which probably means there's some magnesium in it. Okay. So nothing left to do but to titrate it. So let's get our starting amount. We are starting at 20.54 milliliters. And we're going to open this pretty quick here to get through our magnesium that we've added. So we know that's going to take a little bit. And we're going to try and get this kind of rose color to turn blue, just like the other ones here. So I'm starting to see some blue color peek through. That's good. So it's still got a little ways to go. I'm going to slow down now. It was wishful thinking. Oh, now we're getting, so I saw a flash of blue there, it looks like it's fading back to purple, so actually looks like kind of got lucky there, probably put a little too much in. That's very close. Make sure you can kind of see that color difference. It's just a little darker. That's definitely close. Alright, that looks like we have our blue color. So, we are currently at 34.60 milliliters. Then what we can do is we can just compare this amount of EDTA used to the amount used in the last one, getting rid of the magnesium chloride amount from the blank, and then we can compare the concentrations of calcium and figure out how much calcium is in our water. And of course, I'm here in Michigan, so we're a Great Lakes state, so we probably have a significant quantity from the limestone bed of the lakes around us.